Hey everybody, this is Larry. This is me going over Q4 of the bi-weekly contest 71st. Minimum differences in sums after removal of elements. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. And this problem, maybe like all the other problems in this contest, for me anyway, I had trouble reading it. I misread this problem as well, and I think that led to the wrong answer that I had because I was trying to solve the wrong problem. And even though in the end I knew what the right problem was, because I came from it from a weird angle, I couldn't get rid of that that initial bias. So I'll go over my situation very quickly, which is that initially I thought that I didn't think that it was subsequent, so that I thought you could sort it and you could use any numbers in any components and so forth, right? So I misread that for a little while, and of course that is probably NP or close to it, but I wasn't sure. I was trying to figure out whether there was a dynamic programming solution and try to figure out how to break that apart, right? And then the second misread, after I realized, oh, it's subsequence, and you can watch me during the video next where I talk about this. This is a virtual contest that I did it under, so I am more verbose than usual. I talk a little bit more, though I am slower. And the second part is that for some reason I thought this difference is the absolute difference. And what I mean by that is that I thought that, you're trying to get the smallest absolute difference. But only after I kind of look at the examples and reread it, I realized that, oh, you actually want the minimal difference, which means sum of the first minus sum of the second. So after that, I honestly was trying to build a heap-based solution on a greedy idea of, okay, you start with the first third and then last third, and then you try to fight over the middle numbers, right? So that was my idea. I submitted, I got a wrong answer, I was sad. And then after that, I realized that I wasn't greedy. So I was like, okay, maybe there is some dynamic programming solution. I've thought about it, and there is a dynamic programming solution for an obvious reasons, but I'll talk about it in a sec. But then after that, I was like, oh, n is 10 to the fifth still. So the dynamic programming solution that I had in mind was going to be too slow. But right after that, I had an epiphany, and my light bulb just, turned on, and I was like, oh, actually, we just want a very specific thing, which is that, for the first, so basically what this is saying is that we want to select n numbers, max n numbers from the first portion, and we also want to take the minimal numbers from, we want to take the minimum, okay, let me step back for a second. Basically looking at this formula, because now it's not absolute value, there's two ways to get the minimal difference, right? One is to minimize the first half sum, and then the other is to maximize the second half sum. So then after that, it becomes, okay, let me bring up paintbrush real quick. Let me draw this. I don't have my drawing stuff, so this will have to do. But basically, let's say you have, this array, and basically the idea is that, okay, you by default, if you don't remove or subtract anything, or by default you subtract the middle third, you're taking basically, you want, again, I'm touch padding this, not even on a mouse, so this is a little bit weird, but bear with me. You want the minimum of the half, so by default, right, let's say you start with this, right? And then the question is, okay, let's say we look at the first third and plus one number, right? So plus one number. So we want the min of this, and then we take a look, right? And then dot. And then the idea that I thought is that, okay, if I'm doing this, let's say min of the first number, and then the min of the second number, and so forth, right? And then conversely, you can look at this as, so this is getting the prefix min, if you will, right? Which is fine. We could prefix sum of the min n numbers, right? So we take the sum of the smallest n numbers, because that's how you greedily get the min of the first k numbers, right? The sum of the first n numbers of the k numbers, something like that. And then I thought, oh, actually, then in that case, now this becomes, let's say we have the min of this, right? What happens? Well, that means that we can use the max of everything else here, right? And that's basically the way that I would attack the solution is that, okay, let's say we're given this min, then we can take this max on the right side. Let's say min here, we move to the right by 1, that means that max shrinks by 1, right? So that's basically the idea here now, is that we built out how to figure out all the way through. And of course, we stop at, in this case, in the min on the left, we stop when it hits 2/3 of the number, because if we hit 2/3 of the number, we removed, that means that we removed at most n numbers already, right? So we removed all the numbers that we can, and that's why we have these thirds type thing. And that's pretty much the idea behind this one. And after that, it's just brute force of, okay, let's say we have n numbers in the first min and 2 times n on the second min. Or second chunk, we take the min of the first chunk and max of the second chunk. Let's say the first chunk is now n plus 1, and then the second chunk is 2 times n minus 1. Together, they're 3 times n. You take the min of the first chunk, max of the first chunk, and then you do the math. So that's basically the idea. I'm going to skip ahead real quick. So that's basically my idea, is that, okay, let's say you have the first chunk and the second chunk, and then you take the best of these solutions. And then the rest, of course, is just going to be a heap solution. The heap idea is that, okay, you're taking in the first chunk, you want a max heap because you want the n min numbers. So you take the max heap so that you get rid of the max number anytime you put a number in, and then you just kind of keep track of the left sum. Of course, in Python, heap is a max heap, so we do a negative version of that, so that it handles the maximum when you pop. But yeah, and actually this is not necessary. I did it another way, so that's why I had that. But yeah, and then now this is just standard max heap stuff. Let's say the current number that we're looking at, going from left to right, we look at that number. Let's say this number is smaller than the biggest number in the heap. Then we move the left, the smallest number. We remove it. We recalculate left sum by the delta, and then we put it into the heap, and then we put it as the prefix answer, right? And then in the same way, we do the right chunk. We have the sum. We look at if we get a bigger number, then we put it into the heap, and then we push it into the suffix. And then now, once we reverse them and line them up, we can get the best answer from that way. This is going to be O of n log n and O of n space, n log n time, and because we have this O of n thing that does log n operation each time at most, and of course this is just going to be linear. And in terms of space, we have 2 heaps that are linear, so that's going to be linear, right? So yeah, that's all I have for this one. Let me know what you think. Yeah, let me make the code a little bit bigger. Should have done that earlier. But and then this is the second half of the code. But yeah, let me know what you think. Come hang out in the Discord if you want to talk about this problem. But that's all I have. You could watch me solve it live during the contest next. Okay, cool. All right. How far behind am I? Let's see. That took a while. Okay. Yikes. Okay, let's focus. Q4. How much time do I have left? Okay, so I'm 27 minutes in or so. Okay. Nums consist of 3 times n. Exactly n. So basically, what? The difference in minimum? Okay. So basically, you remove 1/3 of the elements, and then you try to do some magic on the other 2 to try to figure out the minimal difference. What is n? N is big. Wow. So okay. Huh. And the numbers of I is pretty big too, so what you might call it, knapsack doesn't seem okay. Huh. I mean, it's probably if we're thinking better, it's probably going to be some sort of weird greedy, but I think I have a hard time convincing myself of it. Oh, wait. I think I misread this for a second, or I misunderstood this problem. So actually, the order matters. For some reason, I thought I could just sort it, which is, like if you're giving. Okay. Huh. What does that? How does that change? It's because now. Okay. That changes things a bit, actually. Now, this is where I wish I had pencil and paper, but because the order matters, that means that the first. I mean, yeah, okay. So we have some n times 3 items. And what does that mean? If we remove, so we remove no numbers per se, or remove the middle third, then it's just the first third, the difference between that. And what if we remove one number from the beginning? That means that we replace a number from the beginning. We place a number from the beginning to one of the middle third numbers, or the first middle third number, and then so forth. And you have this like cascading thing. And then the question is, okay, I mean, I have like this visualization, but what does that mean, right? How many people have solved this? A lot of people have solved this, actually. Maybe not a lot, but a reasonable amount. Okay. What does that mean? So we remove these two, and that means that we remove one. That means that I think the part I'm struggling with is proving greedy. I have a few greedy ideas in my mind. Okay, so let's say we have a sum. This is this is 16, and if we add 5, I think the opposite idea is how I would want to do it. If we add 5, then we delete one of these. So what does 5 represent to us? 5 represent to us a -2 or a -4. But how can we combine that together? If I have to guess, it's going to be dp. How do I even get it? Okay. Well, the one thing that we can do I don't think I have an immediate idea on this one. That's definitely true. Also, I didn't realize that order Why do they make it so that you do -1 instead of? Huh? Actually, wow! I misread this totally. For some reason, I misread it again for the second time. I thought that it is the absolute, because that's usually what they do, is the absolute value, right? So I was trying to, that's why I was thinking about knapsacky things. But now it actually is different, because now you're trying to maximize the second sum, you're trying to maximize the second sum and minimize the first sum. Okay, so now I see that now I see that there can be a greedy because it's not absolute difference. Wow, I misread this twice. Okay, so then now what do we do? So basically we want to maximize the part 2 and minimize part 1. And this, and what does that mean, right? That means that for each number, I think we can, I want to say we can do greedy, and then it's just the 2 pointers or something like that, where you replace the 3 with the 8, and then 5 with the 1, and then you're done. Because, though technically you can actually, what you would do is actually replace the 8 with the 1, and then you have the 8 and the 3, and then the 9 and the 5. So then I guess the idea here is to use a min heap on the right and a max heap on the left, something like that, and then greedily do some maths. Is that reasonable? I'm gonna do it. I don't know if this is true, right, but I think this is enough for me to at least try a YOLO, and then at least come up with a counter case or something. Couple of wrong answers, so I don't know. Could be sketch, but let's see. Okay. Okay. Oops. Yeah, actually that should be fine. Do later. There's like a heapify, but I always, is that a thing? Okay, so that's not a syntax error, so I can use this later. Okay. Making sure we're doing the right thing-ish. Okay, maybe not. I don't know. There's only two. These cases have 2 symbol. Okay, and then now we have left sum is equal to sum of left right sum. Okay, and then now. Okay, so now what we want to do is, let's do something slightly silly, but what's it called? That's the middle third, right? Yep. Okay, cool. And then now, oh, actually, I mixed this up. So we want on the left side, we want. My memory's not good. Okay, so the right side, we want to maximize the right side, so we want to have a min heap, and the left side is max heap. Okay. Left is max heap. Why do I want a max heap? I want a max heap because I want to get rid of the max number. Okay, fine, Larry. This is like exposition on a just so I don't forget. So because we want a max heap, we do a negative number here. Yeah, unfortunately, there's no easy way to do it, right? I don't know. Okay. Okay. Can there be negative input? Nope. So I guess we should be good here. I'm like so. This is what happens when you're not confident about your coding. Is that you do all these things because if you're confident, you don't think about it. But I am a little bit bad today. Okay. So then item. So the beginning of the queue, and then the max. Okay, so we replace the max with the beginning of the queue. Okay, left candidate is equal to. So that means that we subtract this and then we add this in that row. So okay, so this is the contribution from the left side. And then on the right side, we have we remove this. Yeah, remove this and add this. So if so this is the contribution to the answer, and we want the minimum of it, right? No, that's not true. Wait. Well, we want what contributes the most negativeness. So that means that if this is bigger than that, then write some. Oops. Oh, and this is actually negative this as well. Yeah. If the right is the better move, then we do this, and then q dot pop, right? No, just pop. Oops. Else pop left some, and also have to deheap. So then now, right, q dot pop, right, q dot hit push. Yeah, I mean, I think I'm happy with that. Maybe I don't know if this is quite right, because you could end up with a smaller number, I suppose. But you, oh yeah, I guess we can't just ignore it if in that rule, right? If okay, we have to do some maths, but let's finish writing this first. Yeah. I don't even know if this idea is right, to be honest. Because this can, you would only do this if this makes sense. But in this case, then both of them are not great for you, so it doesn't really matter. Okay, then in this case, if this is negative, then we just pop without caring. And then if this is positive, then we also pop without caring, because if it's positive, then we don't have to do it. Also, is that true though? Yeah, no, we can skip that. Yeah, okay. Okay. Where did I have a typo? Best guess. How did that happen? -1 is fine, -12 is less fine. Okay. So we're not really not Gucci. Okay. How did I get -12? What's happening? Okay, I start at -12, so maybe that's why. Did I misunderstood this? Did I misunderstood this form again? So yeah, in this case, you remove these two. Wait, what? Oh, it's first minus the second. Yeah, okay. So you remove these two, and then, did I just have my math wrong somewhere? Okay, I guess so. Oh, I just, okay, I have my signs are wrong. Wow, that is actually pretty sad. I guess I'm just so used to writing it that way. Or like that is how you usually do, I don't know. -1 and 8. 8 is still not great. Or 8 is not the smallest anyway. So at least we know that this idea is wrong, perhaps. Well, this is 16 minus 4. Let's see. Okay. So, okay. Maybe this is just the wrong idea, to be honest. I'm just trying to play around with different greedy ideas. So after one iteration, there should be at least 2 iterations though, so that's a little bit awkward, right? Oh, well, maybe it just continued, actually. But it shouldn't, right? No, maybe it should, I don't know. Let's see. 16 minus 13 is 1. Okay, so that's the idea. So what happened? What am I doing? So this is yikes. Okay, so we can either, what am I printing here? Oh, I forgot. I was wondering why it's just inconsistent. Okay, so that means that we can either replace the 9 with the 5, and then I do. Okay, so greedy isn't working then, because I'm choosing to replace the 9 with the 5 in a greedy way. No, I think I messed up actually. Hang on. I messed up on my signs, because actually 7 is the thing, because we want to increase the right side by 7. So greedy still kind of works here, but I'm just not doing it right, because I'm not doing the signs correctly. Okay, so we want, how do I say in English? Okay, so this has a contribution of -4. This has a contribution of -7 on the right side. So we want negative of this because it is, yeah, okay. Maybe that's right, I don't know. Okay, so that at least gives me the right answer here. I might have to fix this, but basically if, what is this in English? So if this contribution is negative, let's just be consistent, I guess. Even though it looks really awkward. Make sure I don't have the other one incorrect, at least. Okay. Try again in a few seconds. -1 and 1. I'm just going to YOLO really quick, but I have to think about this. Okay, so we're definitely wrong. I really don't. That's a long way to not know the answer, though. That's a little bit sad. So that means that you can do better. So that means that my greedy is wrong and not the implementation. A lot of people got this though, so maybe I'm just not thinking about this in the right way. Maybe it's DP and I'm just thinking about it in a silly way. We want to minimize the first. I guess so. Now that I think about it, I think about having another way of doing it, maybe. No, but I mean, there is definitely a DP, but the DP may be too slow. But I can also, I think another way, I have, okay. But not, it's, okay, fine. Okay, I know what I want to do. Okay, I know how to do this, but that took a long way to go about it. It's not, I mean, it's greedy, but in another way, it's just a for loop, like a prefix answer thing. Okay. 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 I am being silly. This one's not that. This one actually, I like this part, but I didn't know how to do it. Maybe I should have explored a little bit more because I didn't even use this example really, other than to prove my greedy wrong. But okay, so now let's see. Okay, so okay, reset, Larry. You got this. You know how to do this. You know the answer to this one, Larry. Just do it. Okay. If what is it? Num sub I. Okay, if this number is smaller than the left contribution, because we have a max heap, then okay. Yeah, okay, fine. Left sum is equal to left sum minus left C. No, yep. And then add num sub current. Hip q dot hip. Okay, I know how to do this now, but that is not so slick though. Yeah, because we want to minimize the left. Okay, and then prefix that up. Okay. I guess this is actually easier to write, but okay, now in this one, we want the max, right? No, yeah, we want the max, so if this number is bigger, then we want to get rid of it. Okay, fine. Okay. Oh, what the? Why am I writing prefix again? So, okay. So now do I need to reverse it? Yep, okay. Okay, and then now we just have to do a math over this. Oh, whoops. Huh. Mixed up the index and the thingy. Okay. Okay. Hey, oh, I forget to. I always forget. Oh no, that's not it. I just had the wrong one. Okay, so now we have these things, and then now we can. Is this off by 1? Yeah, I guess this is off by 1. Oh, not off by 1, but the left sum is here, and then you combine with the. I think this should be good then. Maybe I'm off by 1 still. Okay, that's not great. I think this is right though. It's just that maybe I have an off by 1 somewhere with my indexes. So the suffix. So this goes all the way to n minus 3. That should be true. Okay, let's see. Yeah, this is 3. This is 2. Okay, 1 this is 2. Okay. This is annoying. I think I'm just off by 1 somewhere though. Basically, you want the max of the things. So left sum is the 1, and then but that contains all the other numbers. Now this should be right on the indexing. Maybe. Okay, let's do, okay, 16, that's right, and on the right side is 13, that's true, and then 12, yep, and on the right side is 11. Okay, no, I mean these, what am I doing wrong then? Do I have an off by 1 somewhere where I'm not taking account a number or something? Oh, this is negative because, yikes, I forgot about the, okay, there we go. The heap, the max min heap type thing is silly. Also, okay, what is an unknown error? Okay, the unknown error is accepted. Okay. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Stay good, stay healthy, to good mental health. And bye-bye from Eddie, and I'll see you later. Bye-bye.